60th power, then I subtract 1, and then I divide this by 0.00079,327. When you do this on your calculator, do this first. So I'm going to do that first. 1.00079,327 raised to the 60th power. And do you want me to write down what I get? I'll write it down. I get 200 times that to the 60th is 1.048727,298. And then I still need to subtract 1 and then divide that by 0.00079,327. So just make sure you're getting this to the 60th is that.
I have a question.
Yes?
On the end, why is it 12 or 12 times 5 instead of 52 times 5 since it's compounded?
The compounding of the interest has nothing to do with the n. The n is how many equal payments you make over the entire period. Okay, so if I'm doing, see there's a distinction here between how often I'm depositing versus how often it's compounded. Another class is having a lot more fun than we are. Yeah, they're watching a movie. Okay. Now, subtract this minus 1, get that answer, and then divide by this. Then multiply times 200. Let's see what we get. Let's see if you're getting the same thing I get. $12,285.17. Okay, I have another question to ask here. How much interest did you earn? So think about it. How much money did you deposit? Did you deposit $12,285.17? No. How much did you actually deposit? What did you put in? You put in 52 payments, right? Of what? Or not 52, sorry. Sorry. You did 60 payments, right? 60 payments of 200. You actually did 60 times 200, which is 12,000. So you put in $12,000 and you earned a whopping $285 of interest. Yes. All right, number 8. You need to save up $5,000 in the next 3 years. All right? You plan to put in money every week into an account with 4% interest compounded monthly. How much do you need to put in every week? All right, is this simple interest? Is this PERT or the other one? Is this PERT? No, because we're putting money in on a regular basis. We put money in on a regular basis, that's an annuity. That's either going to be future value or present value. Now, which one is it? Is it future or present? Future. Why is it future and not present? Yeah, because you're saving up money, right? You need to save money up, and you're going to be putting money in. That's future value. So let's try and fill in all the pieces for this future value problem. All right, do we know the payment? No, in fact, it says how much do you need to put in every week, right? So that's actually what we want to know. Do we know the interest rate? It's 4%. How often is it compounded? Monthly, so I need to divide that by 12. Do you all see that in there? Into an account with 4% interest compounded monthly. So my I is 0.04 divided by 12. Do we know N? This is a little tricky. 3 times 52. Why is this 3 times 52? 3 years, but how often do you plan on making payments? Every week, 52 weeks, right? So what is that? 156? What's the future value? That's what we are saving up for, right? We want to save up $5,000. Just out of curiosity, if we wanted to save up $5,000 and we wanted to put money away, right, bury it in the backyard, we want to do this for 3 years every week, how much would we need to put in every week? We take the 5,000 and divide it by 156, right? What is that, just so we know? 332? Okay, so about $32.05. If we just go and put $32.05 in our backyard, bury it, and we do that every week for 3 years, at the end we're going to have $5,000, all right? But this we showed in class, this is not the efficient way of doing this. We put it in a bank, it's going to earn interest, right? Our money will earn money. So we should, when we're done, get a number smaller than 32, right? Okay, let's plug everything in. Our future value is what? 5,000? That must equal payment, which I don't know, times, now, we never did the 0.04 divided by 12. Ooh. Okay, 0.003333. I'm going to go with 4 threes. So what goes right here? Top left. It's 1.003333 raised to what power? 156 minus 1 over 0.003333. Any questions on plugging that in to the formula? Let me figure out what this is right here. 1.003333 raised to the 156th power. I get 1.6804866655. I subtract 1 from that. Okay, so after I do this on my calculator, I subtract 1, I get an answer. My answer is 0.6804866552. And then I take that and divide that by this. I get 204.16, something like that. So here's where I am. 5,000 equals payment times 204.1664, something like that. Are we all good with how I came up with 204.1664? Now what? I'm trying to solve for payment, right? So divide both sides by 204.1664. Divide this side by it and that side by it. So I'm taking 5,000 and dividing by that number, and I'm getting 24.49-ish equals my payment. So instead of going and dumping $32 into our backyard every week for 3 years, I can go dump $24.50 into the bank, save myself a little money, right? Be able to go buy that Whataburger or something, right? Every week that I want. And then I'll still have 5,000 at the end because it's earning money for me. I'm not saying you shouldn't should not bury money in your backyard. I'm not saying you shouldn't. Just saying if you put it in a bank, it's going to earn money for you. All right, let's look at number 9. How are we doing here on time? I feel like we're cutting 5 minutes. All right, number 9. You want to be able to withdraw $2,000 a month from an annuity earning 5% interest compounded quarterly. You need to be able to do this for 10 years. How much do you need to put in now? This is present value. Because you're going to be taking money out over time, right? So you're going to start, you're going to put money in the bank. I actually saw a commercial for an annuity last night. I never really paid attention to annuities, but I heard it on TV and I was like, oh yeah, there's an annuity. Some bank offering people who want to retire an annuity. Okay, so we're going to be using present value formula, which is payment, and then the formula gets kind of funky. It is 1 minus, and then you have 1 plus I raised to the negative n over I. But as far as how you get I, how you get n, everything is the same. So for 9, what do we know? Do we know the payment? Do we know I? Do we know n? Do we know the present value? So what? We don't know payment, or we do? You want to be able to withdraw, right?
You're like paying.
You're paying yourself, exactly. So your payment is $2,000. Do we know the interest rate? 5%, so 0.05, but I need to divide it by how often it's compounded. It's quarterly, so 4. Do we know the total number of payments, or payments to ourselves? Do we know the total number we want? Well, how often are we taking out the money? Monthly? And how long do we want to be able to do this for? 10 years. Right? So isn't that 10 times 12? Equals 120. Do we know the present value? No, this is actually what we want to know, isn't it? We would like to know how much money do I need to go dump into the bank right now to be able to pull $2,000 out every month for the next 10 years. So let's plug in. Present value we don't know, equals 2,000 times, and then we have 1 minus 1 plus, what is that? 0.05 divided by 4, just to be sure, 0.0125. Raised to the 120, negative 120. Let me write down what this is. This is 0.0125. That's where I'm getting this from. All right, 1.0125 comes from 1 plus I. Here's what I is. And then negative 120. Do not forget that negative. If you make it positive, it's going to be over. Okay, because of time, let me just grind that calculation out. I'm going to grind the whole thing out and see what I get. Anybody want to share what they get, total present value, how much we need to dump in? $123,965 and some change. That's how much we will need to dump in. I think we saw this was pretty dramatic when we compared that to, let's say you don't put it in the bank and you want to have $2,000 every month for the next 10 years. How much would you have to go bury in your backyard? Yeah, if you multiply this times 120, you get $240,000. So you need more. You need over $100,000 more buried in your backyard if you want to do the same thing, right? So these annuities are smart options, aren't they? As long as that interest rate is fixed, you should be in good shape. Okay, last one, number 10. We may not have time. We're out of time. Can we just set it up? You buy a $2,000 TV at 15% interest per month. It must be paid off in 18 equal monthly payments. What is your payment? So what is this? Future value, present value? Present value. You're starting with the balance of 2,000, aren't you? And then you're going to dwindle it away. You're cutting away at it. This is the same thing as putting money in the bank and taking some out every month. So we are at present value formula. Do we know the payment? No, that's the question, right? Do we know the interest rate? 15%. It's compounded how many times? Monthly, right? So 12. Do we know N, the total number of payments? This one's tricky.
18 equal monthly payments.
Yes. N is always the number, okay, well let's do it this way.
So is it 18 times 12?
Well, no, because N is always the number, the total number of equal payments, right? The total number. And I'm doing how many? 18. So like here for this one, you don't have to compute what N is. It's given to you directly. 18 equal payments. That's it, right? Okay. So now you'd plug in and we would solve for payment. Oh, wait, present value. What's present value? 2,000. Okay. I will calculate this. I'll write it on the board. Y'all can pack up if you want to leave, you can. But I'm going to finish it out. And we'll have our test Tuesday, and then what is it? Is next week Thanksgiving? Okay, that's the calculation there.
So you can stick basically that whole thing in your calculator.
You could, as long as you're doing it correctly and you're making sure you're careful, yes. There is some parentheses issues you might have to deal with. So I get 2,000 equals payment times 16.0295, and I divide both sides by that. 124.77, around 77 equals your payment. There you go. Yeah, so I ask also how much interest did you pay? So how many payments did you make? How much did you pay each payment? So 18 times 124.77. Okay, your total payments was 18 times 124.77, which means that you paid $2,245.86. That's how much you paid in total. So how much interest did you pay? $245 in interest. Because the TV, right, you bought it for $2,000, but at the end of the day you wound up paying $2,245. So how much, percentage-wise, how much is that? Like $245 divided by 2,000, it's about 12%. It's about 12%. But what was the interest rate? 15? Yeah, well, the reason that happened is because you paid it off pretty quick. You know, I mean, so, all right, we're good.
Sir,
Yes.
I told you I was going to be at your test Monday.
Yes.
Monday, but I'm actually going to come on Tuesday.
You're going to be here?
Yeah.
Did you email me?
No, I didn't.
Okay, then don't worry about it. Just be here. Tuesday, you mean?
Tuesday,
Be
yeah.
here Tuesday.
It's
Okay.
not a long test, right? It's about normal length?
Yeah, it'll be a normal class period.
Okay.
Yeah. All right.